everything you do on a computer begins with just 8 bits. Watching videos, playing games, listening to music, browsing the web, even talking to AI. Behind every app, every image, and every file is the same tiny building block, just 8 bits. But how can something so small create an entire digital world? Let's find out. Before we understand a byte, we first need to understand a bit. A bit is the smallest piece of information a computer can store. Think of it like a tiny switch. It can only have 2 possible states, off or on. Computers represent those 2 states using the numbers 0 and 1. Everything in computing starts with these 2 simple values. 1 bit alone can't store much information, but when we combine 8 bits together, we get 1 byte. Each of those 8 positions can be either a 0 or a 1. That creates 256 unique combinations. Every byte is simply a different pattern of 8 bits. Those patterns are what computers use to represent information. So where do these bits actually live? Inside every processor and memory chip are billions of microscopic electronic switches called transistors. Each transistor stores a 0 or a 1 by controlling the flow of electricity. Billions of these tiny switches flip on and off every second. Together, they store, process, and move all the information inside your computer. A byte doesn't automatically mean anything. It's simply a pattern. But when computers follow a standard like ASCII or Unicode, those patterns become letters and symbols. For example, one specific binary pattern represents the letter A. Every email, document, and website you read is built from these binary patterns. Bytes can also represent numbers. With 8 bits, 1 byte can store any value from 0 to 255. That might seem simple, but computers use these values everywhere. Counting, measuring, calculating, and controlling how software behaves. What about colors? Computers build colors using 3 channels: red, green, and blue. Each color channel is stored using 1 byte. That means each channel has 256 brightness levels. When those channels are combined, they create over 16 million different colors. That's how every photo, game, and video gets its vibrant appearance. Images are made from tiny squares called pixels. Each pixel stores its own color using bytes. When millions of pixels are placed together, they form the pictures you see on your screen. Zoom in far enough, and every image becomes a grid of tiny colored squares. Videos work the same way. They're simply a series of images called frames shown one after another. When those frames are displayed quickly enough, your brain sees smooth motion. Every frame is made from pixels. Every pixel is stored using bytes. That's why videos can take up so much storage space. Sound also becomes bytes. A microphone measures sound waves thousands of times every second. Each measurement is converted into numbers. Those numbers are stored as bytes. When you press play, your speakers convert those bytes back into sound waves. That's how you hear music, podcasts, and even this voice. Now imagine billions of bytes flowing into the CPU. The processor reads them, performs calculations, makes decisions, and sends new bytes back out. Every click, every animation, and every app running on your computer depends on this continuous stream of data. Bytes need somewhere to stay. RAM temporarily stores the information your computer is using right now. SSDs and hard drives keep your files even after the power is turned off. Whenever you save a document or install a game, you're simply storing billions of bytes. Bytes don't stay on just one computer. Whenever you visit a website or send a message, your data is split into small pieces called packets. Those packets travel through routers, cables, and servers across the internet. Once they arrive, they're reassembled into the original information. That's how the internet delivers data around the world in just seconds. Photos, music, videos, games, documents, websites, artificial intelligence. Although they look completely different, they're all built from the same foundation. Different patterns, different meanings, the same bytes. 1 byte may seem incredibly small, but computers combine bytes into larger and larger units. 1024 bytes make 1 kilobyte. 1024 kilobytes make 1 megabyte. 1024 megabytes make 1 gigabyte. 1024 gigabytes make 1 terabyte. Together, these tiny building blocks store everything in our digital world. It's amazing to think that everything in the digital world starts with just 8 tiny bits. Every photo you take, every game you play, every video you watch, and even the AI you use every day all begin with the same simple building block. That's the incredible power of a single byte. If you enjoyed this video and learned something new, don't forget to like the video, share it with someone who's curious about technology, and subscribe to TheBitflow for more visual explainers that make technology easy to understand. Thanks for watching. Keep learning, keep building. I'll see you in the next one.